Everything that we have seen on Earth and in the universe only makes up 4% of the matter that actually exists. The rest of the universe is composed of a substance that scientists have recently stumbled on. Dark matter. Dark matter makes up roughly 26% of the universe, and dark energy makes up the rest. Dark matter can't be seen. It is invisible because it does not absorb, emit, or reflect in the electromagnetic spectrum. However, we know it exists because of its gravitational effects. It happens to dominate the gravitational effects in the universe on a large scale. Let's talk about the evidence for dark matter and how we know it exists. In a galaxy, stars that are closer to the central bulge should travel at a faster rate than the stars on the outside. We see this in our solar system, where the inner planets have a faster orbit than the outer planets because they're closer to the sun. It would be expected for the velocity of the outer stars to be less than the inner. However, scientists have noticed that the stars on the outer edge of the galaxy travel at a similar velocity than the stars on the inside. The velocity is constant. This means that the outer stars feel the gravitational effects of some matter that is not visible to us. This led scientists to hypothesize that all galaxies must be embedded in a cloud of dark matter that exists over a really wide range and dominates the structure and properties of a galaxy. More evidence comes from observing many galaxies in a cluster. When measuring the orbital velocities of the galaxy, their mass can be calculated. However, there is more mass present than what can actually be accounted for. So, to draw an analogy, pretend that you bought a bag of chips and it's set to weigh 50 grams, but when you actually weigh it, it weighs much more. Now, where did that extra mass come from? A similar situation occurs when observing the mass of a galaxy cluster. The extra mass is the result of the cluster being embedded in a cloud of dark matter that is 10 times its actual size. Another clue comes from observing gravitational lensing effects, which were predicted by Einstein's theory of general relativity. Pretend that an observer from Earth is viewing a galaxy. We can see it as a ray of light travels from the galaxy for millions of light years until it reaches us. We can deduce the location of the galaxy by tracing back the direction of the ray of light. However, if a cluster of galaxies were to be placed in the middle, embedded in a dark matter cloud, the rays would bend around its gravitational field. The gravitational field, due to mass, will deflect the trajectory of the light particle itself. So the light ray coming from the galaxy can bend and end up coming to Earth. If we extrapolate the ray backwards, the observer sees the galaxy in another position. Because we live in a three-dimensional universe, the rays of light from the distant galaxy coming from anywhere can form a cone-like shape, and to the observer this appears as a ring, known as Einstein's ring. This Einstein ring only occurs when the source, the deflector, in this case is the dark matter, and the observer are all aligned.